Nobody has ever looked straight up out of the solar system. Not sideways, not at a distant galaxy. Straight up, perpendicular to the entire plane of the planets. And what is up there, directly above us right now, is one of the strangest things in the galaxy. Most people never even ask the question, because we have spent centuries looking outward, at stars, at nebulae, at the edge of the observable universe. Nobody thought to look perpendicular. That turns out to have been a mistake. Our solar system sits inside the disk of the Milky Way, a flat, rotating structure roughly 100,000 light-years across. Every planet, every moon, every comet we have ever tracked. All of it moves within that single plane, but the disk itself is tilted, about 60 degrees relative to Earth's orbit around the Sun, which means that when you point straight up out of the solar system, not toward any star, not along the plane, you're pointing out of the galaxy entirely, through the disk, into whatever is on the other side. That direction has a name: galactic north. It points toward a dim patch of sky in the constellation Coma Berenices. The opposite direction, galactic south, toward Sculptor. Neither looks like anything special from Earth. They are the exits, and we are not stationary in that disk. We are moving through it, bobbing, like a horse on a carousel, except the carousel takes about 230 million years to complete one rotation, and the bobbing takes about 30 to 35 million years to cross from one side to the other. Up there, past the disk, something enormous is waiting. We crossed the midpoint roughly 3 million years ago, moving upward, toward galactic north. The next crossing is tens of millions of years away. That rhythm, it turns out, may not be as harmless as it sounds. Let us start close, very close, galactically speaking. Right now, the solar system sits inside something called the local bubble, a cavity in the interstellar medium where the gas is extraordinarily thin, about 1,000 light-years across. We are not surrounded by typical galactic material. We are inside an emptied room. It was not always here. Beginning roughly 14 million years ago, a series of roughly 15 supernova explosions in our galactic neighborhood blasted the surrounding gas outward over millions of years. The shock waves cleared a sphere around us. And then, for millions of years, nothing much seemed to happen. In 2024, a team led by Theo O'Neill at Harvard published a new three-dimensional map of the bubble's surface. They found that it is not a sphere. In the direction of galactic north, directly above the solar system, the wall breaks open. The researchers call it a local chimney. The supernova-driven material did not just expand outward, it burst through the roof of the galactic disk. It started funneling interstellar gas upward, out of the disk, into the halo above. So directly above us is not empty space. It is an exhaust pipe, a channel carved by ancient explosions, still venting, pointing into something much larger. But that is just the door. What is up there, past the chimney? Not what you would expect. The galactic halo. It is not a disk. It is a sphere, a vast, nearly invisible cloud that surrounds the entire Milky Way and extends far beyond anything you would call the galaxy in a photograph. Almost no gas, almost no dust. But something else. Ancient stars. Some of the oldest objects in the galaxy, born more than 12 billion years ago, when the Milky Way was still assembling itself from smaller pieces. And scattered among them, globular clusters, tight, spherical swarms of up to 1 million stars each. More than 150 of them orbit through the halo, taking hundreds of millions of years per lap. These are not young structures. They are remnants, fossils of the galaxy's earliest phase. The halo extends hundreds of thousands of light years in every direction. Above, below, sideways. It dwarfs the visible disk. And the strangest part? It is not the stars that matter here. What comes next is the part that still does not add up. Gaia, the European Space Telescope, has been measuring the positions and velocities of over 1 billion stars. From that data, researchers have calculated the total mass of the Milky Way within about 65,000 light-years of the center, 1.9 times 10 to the power of 11 solar masses. That number is almost meaningless on its own. So here is what it means. Most of that mass is not stars. It is not gas. It is not anything we can directly detect. Most of that mass, somewhere between 80 and 90% of it, is dark matter. We cannot see it. We cannot touch it. We infer its presence because the stars in the outer disk orbit too fast. Something is holding them in, something massive, invisible, and distributed in a sphere that extends above and below the galactic plane far beyond the visible disk. This is the dark matter halo, the largest structure associated with the Milky Way, and it is directly above and below us, in every direction, right now. Here is where it gets personal. As the solar system bobs through the galactic plane, some physicists have proposed that a thin disk of dark matter concentrated along the midplane might gravitationally disturb the Oort cloud. The Oort cloud is a vast, distant shell of icy objects, far beyond Pluto, possibly up to 1 to 3 light-years out. It sits at the very edge of the Sun's gravitational grip. Nudge something there, and the Sun itself pulls it inward. It is gravitationally fragile. A nudge from a passing star can dislodge comets. A nudge from dark matter might do the same. If that happens during each galactic plane crossing, comets fall inward. Some toward the Sun, some toward Earth. Paleontologists have identified cycles in the fossil record, periods of elevated extinction, recurring roughly every 26 to 30 million years. Crater records suggest elevated impact rates on the same schedule. The galactic plane crossings, same timescale. 3 independent datasets, 1 rhythm. That is not proof, but it is the kind of coincidence that does not let you go. Before we go further, this is contested. The correlation between galactic plane crossings and mass extinctions is debated. The timing uncertainties in the fossil record are large enough that some researchers argue the periodicity is not statistically robust, that we are pattern-matching noise. Others point to volcanic activity, to orbital mechanics, to Earth's own internal dynamics as explanations for the same cycles. Cosmic causes are not required. The dark matter disk hypothesis is speculative. No one has directly detected dark matter anywhere. We know it exists because of what it does to visible matter. What it actually is, how it is distributed, whether it forms a disk or a smooth sphere near the galactic midplane, all of that remains genuinely open. The correlation may be real. The mechanism may be completely wrong. Both things can be true. The universe does not owe us a clean answer. But that does not mean there is no signal in the noise. Step back far enough, and this is the picture. Our solar system is not sitting still in a quiet corner of the galaxy. It is orbiting the galactic center, bobbing through the disk, embedded inside a supernova-carved bubble that has punched a chimney through the galactic roof. Above that chimney, a halo of ancient stars and dark matter. A sphere so large it almost touches the halo of our nearest galactic neighbor, Andromeda, 2.5 million light-years away. Below, the same. And somewhere in that invisible mass, there may be a gravitational signal, a rhythm, one that reaches all the way down to the fossil record. I find that genuinely hard to hold in my head, that the extinctions recorded in limestone could be connected to something that large, that old, that far away. But the data keeps pointing in the same direction. We are not just passing through the Milky Way is passing through us. The next time you look up at the Milky Way, that band of light crossing the sky, remember what you are not seeing. Above it and below it, ancient stars, ancient explosions, and a vast, invisible mass that has been quietly shaping this planet for longer than multicellular life has existed. Whether or not the extinction cycles are real, whether or not the dark matter disk exists, the structure is there, the chimney is there, the halo is there. We live inside something enormous. We just rarely look perpendicular to it. Thanks for watching.